recording. So I'll probably do this fairly quick here. But yeah. Okay. So part one. I'm gonna. This lab is already like probably the biggest lab in the because we do both of these things and this. I'm going to I'm going to take out part one as well. Okay, so part one, what I wanted you to do there is to basically recreate slope using the raster function calculator. Okay, like to think about how you would do that. Okay, and so that when I did that in the lecture, I talked about it right here. Okay, so we're basically recreating this this map. Okay, or these two kernels. So if I did that here in this map, let me turn off the zones and the XGrid. I got all these values. I'm going to leave Shasta on, okay? I'm going to turn this off, close all those for a little while. Okay, so I want to recreate, like let's say the slope tool did not exist. So that's what this is saying. So we want to use the raster function calculator to create a slope tool. And so raster functions, if I the four kernels discussed in the four nearest kernels discussed in class. So local, oh, it's called the cell. No, it's neighborhood, right? What's it called? Neighbor focal statistics. There we go. So focal statistics will allow us to run a. It will basically allow us to create any kernel that we want to, and if we want to do the four nearest kernel, it looks like the kernel looks like this. So we would need to put in that we wanted to do weights, and then make our own kernel, which would be, if we want it to look like this, it's all zeros except for a -1 and a 1. So 0, 0, 0, 0, 0, 0, 0, and then this is -1. Okay. So I'm gonna go ahead and run this on elevation, the Shasta data set. And I don't want it to be the mean. I want it to be the sum. So in other words, it's gonna multiply everything by its weight and then add them all up. So that'll be the sum. Okay. So I'm going to create a new layer of that. And so this output layer right here is the east-west differencing value. So where is it? It's called focal statistics Shasta. I'm going to call this. Another way to say that is it's the change in x. So I'm going to call this. I'm going to rename it. And call this delta x. So it's a change in x. And I'm going to rerun the same thing on Shasta. 3 by 3. It's going to be a weight, and then it's got to be sum, and it's going to be 0, 0, 0, 0. Go back here. -1 is the one below. Right. Now this is that one. Create a new layer. This is delta y. So if we zoom in, like I want to zoom in to see an individual raster. Yeah, I can see individual raster cells right here. I want to put this cell right there. This is just an example. Move Shasta up to the top. Okay, so I got my delta X, my delta Y. So I'm going to click on this cell right here, second one over, and the delta X is 10, negative 10. Okay, for that cell right there. I have to remember which cell I pressed. It's this one. I'm going to turn on the Shasta grid, and it's hard to see the cells, but if I move over one, the value was 41.42, and if I move over this way, it was 41.32. So 32 to 42, that is a difference of 10. See that? So that's what I did, is that delta X is the difference going this direction. And the delta Y here is 15, so I should see same thing. If I remember, this is the cell we're talking about. So right there, if I go up one cell, I get 41.28. If I go down one cell, I get 41.43. 28 to 43. 43 minus 28 is what? Is it close to 15? Yeah, I think it is. 43, yeah, plus 2, yeah. That's close to 15. So that's the value. So I found all the values I want. In other words, I've calculated the top part of this numerator. In other words, I've calculated the delta, the change in z with respect to the change in x. Okay. So if I want to continue on my path to calculate slope, I would then do divide and say, take my delta, oh, you can't drag and drop. So delta x divided by, oh, I don't know what the cell size is, because it's not the same as the example. The cell size is 10. Oh, it is the same. So it's 20 here. And I run that guy. So now this is, I'm just going to do it again real quick. Actually, I can leave it as divide delta x. I know what that means. Delta y divided by 20. Run that. So now these two cells represent the entire, this entire formula. So the output here is, these values are these values right here, this value and that value. Okay. So divided each one by 20. And I got a number to represent that value. Let's zoom back out and see what these look like.
Are you recording that?
I am, but I am going to not make this part of the assignment. But I'm trying to.
Of the assignment?
What's that?
Is this part one of the assignment?
Yeah, but I'm gonna delete it since there's already so much work to do in the other two parts of the assignment. I'm just showing you that you can reproduce slope. And so finally, I need to do this part of the equation. So I need to square both of these first. So I'll go to square. So I'm going to square the divide delta y, and I'm going to square the divide delta x. Okay, now those doesn't look like there's any data in. That's because the data now is so large. So now I'm going to add them together. See, that's the next thing, is add them together. So I'm going to add the squared delta x and the squared delta y. And then that is adding them together. Then I'm going to take the square root. Square root is the same as The square root is the same as raising to the 0.5 power. So I take that. So there's the square rooted values. I do want to see what this looks like stretched different. So there we go. So there it is, stretched different. Histogram equalize. Well, histogram equalize will always give you a range, no matter what the real range is, even if the real range is really high. Okay. So that's the histogram equalized. Divide delta x. So this is everything. This is the slope in percent, by the way. Let's look at the histogram here. So we've only got a few values that are way up there. So another way to do this would be to select, like to go from, I don't know, 0 to something else. Choose our own values. Okay. So finally, what we want to do is take the atan. I'm pretty sure that's what it is. Let's see if that works. Raster functions. atan 2, I think, is what we want. No, that requires 2 inputs. Check this, the inverse tangent. Oh, oh yeah, that must be what I want. Okay, so take this, run it, yeah. And then we have values that range from 0 to 1.5. And so those are in radians. So we need to multiply that by 57 something radians 2 degrees. That value. Create new layer. So now this output layer ranges from 0 to 89. And let's symbolize it using histogram equalize. Okay. So that is the slope. So if I click on, out here, the slope is 7 degrees, and I click the slope in here, and it's 38. Okay. So the reason that I originally had this, had you calculate this, is to show you that there will be some differences between doing this and doing just a slope, because we only did the 4 nearest neighbors instead of all of them. So here is this. Now we're just going to calculate the slope of Shasta in degrees, run it, and that's it right there. Okay. So how could we find out how different they are from each other? So I've got this one that represents the canned, and it's using the 8 nearest neighbors to calculate slope. And I calculated slope on my own doing this. It's one of the nice things about the raster function chain. So that was the method that I used to calculate slope on my own. It's nice that there's a slope tool, right? Because I don't have to press all those buttons every time I want to run slope. Okay. But how would I look at the differences between these two data sets? Like if I wanted to see where, because the slope's going to be pretty similar, right? Like, let's zoom way in so we can see some cells. Yeah. Okay, so I'm going to click on that cell right there. So the ArcGIS slope says the slope is 18.78 degrees, and I calculated it as 19.14 degrees. And the reason it's different, I'm telling you, is the same reason why this one says 23.5. On the next one, it says 22.9. Which one's better? Who knows? Lots of researchers have studied the problem, and they decided this one was the better one to implement. But neither one of them is the true slope. And so in our case, we don't have any way, but they're very related. Anyway, to answer your question, to answer my question, sorry, the way I'd find out the difference between the two is to just subtract one from the other. So I'd subtract the one I created, my slope, versus the ArcGIS slope, and there's my output. Now, you can see that there's not a whole lot of, the range isn't huge, but there are areas where my slope is 16 less degrees than ESRI's slope, and there's areas where my slope is at least 14 degrees higher. And this is a map of the areas where our slopes are different. And it makes sense that our slopes are more different, kind of like on the edges of things, not in a uniform slope area. So anyway, that was the idea behind I think I just already had it open, right? No, I didn't already have it open. Way too many windows open.
What we need to actually submit.
Okay, so if I take that off, you will need to submit the toolbox that we created together. So that's in the catalog project. Sorry, that's this toolbox, that TVX file. So you need to turn that toolbox in, and I'm going to modify it right now. I'll go back to my office and make it so that you have to turn in the table that has the surface normal vector average slopes in it. Okay, so you'll have a column that you create that. Is this it? No. You have a column that you create that you calculate a new field based on this formula, right? Nope. This formula right here. Sorry, this formula right here. You're still going to have to do this part 2. So I'm going to rename part 2 part 1 and rename part 3 part 2. And then I'll throw this out. I demonstrated in class right now. Okay. So where do the larger differences occur? I did that. So you don't need to do any of this. You need to turn in a certificate for doing part 2. You need to turn in the toolbox, and you need to turn in just the table with this value calculated into it. Okay, but you're gonna, whatever your field names are, they might not be some X and some Y. You need to change your field names to be the field names that you have in your table.
Data management tool one, or we use the GHY analytics desktop tool one. For the calculate field part.
I'll come look at that. The easiest way is just right click on the field and say calculate field.
Okay.
Data management tools is the one that it's using. So when you right click on the field, it'll have that filled out. Yeah, so you need the field names, whatever field. You probably want to add a new field first. Right? To the table, add a new field, and then you also.
That's the average slope, the name of the field you use.
Yeah, that'd be fine. Mean slope, average slope.